you're going to have the opportunity to prove lots of conjectures. You've rotated triangles to create parallelograms and used congruent parts of congruent triangles to justify that opposite sides are parallel. But there's another way to create these proofs. In 7-6.3, we're told that Ansel wants to prove the conjecture if a quadrilateral is a parallelogram, then opposite angles are congruent. So we can break that conjecture down. If a quadrilateral is a parallelogram, here are your givens, then opposite angles are congruent. Here are your prove-its. So these are my givens here. I'm going to write a 2-column proof. If a quadrilateral is a parallelogram, so TW is parallel to UV. TU is parallel to WV. Now, we've kind of taken an inventory of the properties of some of these figures, including the parallelogram, so you know that opposite angles are congruent, but let's prove it. Do we agree that in this case, angle A is congruent to angle B because they are alternate interior angles with parallel lines? And do we also agree that angle C is congruent to angle B because corresponding angles. Now, these are different corresponding angles than those you would find in corresponding parts of congruent triangles. These are corresponding angles created by a transversal and parallel lines. So these lines actually continue on, and B and C should look familiar to you as corresponding angles created by parallel lines. And that gives us one pair of opposite congruent angles. We can say angle A is congruent to angle B. C, that is. And that's because if B is equal to C, C can be substituted as B here. So this is simply a substitution step. And let's go ahead and call this angle C. Oh, no, we have a C. Let's call it D. Angle D plus angle B equals 180. And that's because they are supplementary. I can add to my alternate interior angles with parallel line step that angle C is congruent to angle E. We'll call this angle angle F. Angle F plus angle E equals 180. I don't actually need a new step number for that because I can simply add it to step number 5 because these are supplementary angles. Now, if we've already shown that E is congruent to C and C is congruent to B, we can say that angle E is congruent to angle B. Can you tell where I'm headed here? This is a substitution step. Therefore, angle F must be congruent to angle D because angles that are supplementary to congruent angles are congruent. Basically, by subtraction, if I take 180 and I subtract a fixed amount, I will get a reliable result. Angles F and angle D must be congruent because of the subtraction from 180. Opposite angles must be congruent. Thus, it is shown.